All right, thanks. So I'm going to start today providing a little bit of background about managing catfish in the Ohio River and hopefully a little bit of context for the reasons we conducted this work. The Ohio River supports really unique and popular trophy fishing opportunities, and really bordering the state of Ohio, it's the only place where anglers can go to catch trophy blue catfish in the state of Ohio. We have many active clubs, we have local, regional, national tournament events, so we have really popular, really important recreational fishery. Obviously, it's a shared resource of border water. We have 6 states and 981 river miles to manage. We do this through the Ohio River Fisheries Management Team, the ORFMT, which is the state fish and wildlife management agencies that border the river. Very recently, we've had quite a bit of conflict between recreational and commercial users. So there's a commercial fishery that's mainly focused on harvest of large and trophy-sized blue and flathead catfish to support the pay lake industry. And if you want to know more about that, we can certainly talk about it, but it's private, small places that stock wild-caught fish, and then they charge patrons a fee to come fish for them. So we have these recreational users and commercial users all targeting trophy catfish. So we have lots of pressure from angler groups to do something about this, to tamp down the harvest of trophy catfish. We have new harvest regulations by many ORFMT states that are designed to do exactly this, but we have extremely limited data. Outside of some sampling Kentucky's been doing over the last few years, we really don't have a lot of information on these populations. And so we need this quality data to assess populations and figure out whether or not these regulations are having any kind of effect. And so we're working right now to develop catfish methods, and again, this is kind of pioneered by Kentucky. This is one small piece of that work. So one of our primary tools is low-frequency electrofishing. This was identified by Bodine 2013 as the most efficient method for capturing blue and flathead catfish. But methods are really inconsistent among sampling entities. A lot of us apply it. We all do it a little bit differently, and it's really poorly described in text like the AFS Standard Methods book. Right? We all kind of do things differently, and there's not a lot of guidance on exactly how to do low-frequency electrofishing. Just to illustrate this point, I briefly went through the Catfish 2010 book to try to identify the papers that use low-frequency electrofishing, and I've got them sorted here kind of in order as they appeared in the book. And I certainly am not trying to call anybody out here, but just to point out how we all kind of do things a lot differently. And there's studies that happen all over the Midwest and Southeast United States. We kind of all use 15 pulses per second with a few exceptions, but that's kind of one area where we do okay. The power in terms of average amps that people try to put in the water varies all over the place. The sampling period, when sampling actually occurs, again, all over the place from spring, summer, fall. It kind of happens at all times of year. And then the focus of my talk today, which is this chase boat piece. Many agencies use chase boats, some don't. And so that's kind of the question we're after today, with the goal of comparing the single versus chase boat configuration on the Ohio River for blue and flathead catfish. So really simply, the chase boat or the single boat configuration is nice because we can sample more locations. In the Ohio River, we have 981 river miles. It requires quite a bit of effort spread spatially, and a single boat allows you to visit more places and cover more water. Logistically, it's a little bit easier too. You only have to arrange a single boat instead of 2 boats and 2 crews. And quite simply, the chase boat might catch more fish and be more efficient. So the central question here is the chase boat worth the spatial sacrifice and the number of sites that we can hit? So my objectives, specifically, compare this single boat versus chase boat configuration. I'm going to look at CPUE and size distributions and the effort needed to achieve precision and catch objectives, and I'll describe those in a moment. So to provide some methods, our single boat configuration, we had 2 dipnetters on an electrofishing boat, and so the electrofishing boat was responsible for capturing all the stunned fish. Our chase boat configuration, we had 2 dipnetters on the electrofishing boat plus 2 dipnetters on a chase boat. Both boats participated in catching the fish. We randomly assigned this configuration. We used 15 pulses per second. We standardized power based on the Miranda 2009 tables and AFS standard methods, and we can talk a little bit later if this was an appropriate decision or not. We conducted 15-minute transects, and we randomly chose sites based on river kilometer. So what this sampling looked like spatially, in 2018 we sampled the Greenup Pool, which is kind of at the very southern tip of Ohio. In 2019 we sampled the Greenup Pool again, and two additional pools, the Racine and Pike Island pools, a little bit further upstream. In total we sampled 104 sites. We caught over 1,000 flathead catfish and only 163 blue catfish. And part of this, we're kind of new to this work. We didn't really know what to expect with blue catfish in many of these pools, and we really didn't catch very many. So first, looking at CPUE and size distributions. So I'm going to present these results from kind of downstream to upstream, starting with the Greenup Pool. So these box plots have the chase boat catches, the CPUE on the y-axis, chase boat catches versus single boat catches. And so Greenup Pool in 2018, we obviously caught more fish with the chase boat than the single boat. And this holds true for Greenup Pool in 2019, the Racine Pool, and the Pike Island Pool, right? All the pools that we sampled, we generally caught more fish with the chase boat than with the single boat. So this kind of computes the 49 flathead catfish per hour with the chase boat versus 34 fish per hour with the single boat, and these were significant based on linear mix models. And so one other thing I'll point out here is with the chase boat configuration, we had these high catch events, over 100 fish per hour, that we observed kind of in every single sampling event that we just didn't get with the single boat. So I want to kind of point that out now and keep that in mind as I move through the talk. So now looking at blue catfish, remember we didn't catch nearly as many blue catfish, but in general we had slightly higher catches in the Greenup Pool in 2018 using a chase boat, fairly similar in 2019. The Racine Pool, again, we catch more fish with the chase boat, and we caught no blue catfish in the Pike Island Pool. So the chase boat, about 10 fish per hour, single boat, about 4 fish per hour, and again, this was statistically significant using linear mix models. And kind of similar story to the flathead catfish, we had these instances of high catch events with a chase boat that we just didn't observe with the single boat. So now looking at size distributions, and I kind of changed the format here, but I'm going to step through kind of each one individually. So I have the single boat on the top and the chase boat on the bottom, and these are length frequency histograms, so millimeters along the x-axis and the number of individuals on the y-axis. And really, I'll just point out here that we caught sort of a mix of small and large individuals. And so this is Greenup Pool in 2018, Greenup Pool in 2019, and I'll just kind of go through these fairly quickly. Again, kind of a mix of large and small individuals, because we really didn't find any significant differences in size distribution based on KS tests to test these distributions against one another. So no real size distributions, differences for flathead catfish between the configurations. Blue catfish, kind of a similar story. This is the Greenup Pool in 2018. Again, fewer fish represented here, but in general we get kind of this mix of large and small individuals. Greenup Pool in 2019 and Racine Pool where we caught very few fish. And again, no significant differences here in those length distributions. So now moving on to the second objective, looking at the effort needed to achieve precision and catch objectives. And really quickly what these are. Our precision objective was relative standard error of CPUE among sites of less than 25%. So we're looking to sample enough sites to get precise estimates of CPUE. And our catch objective is to capture 100 stock length individuals, which is kind of the gold standard for size metrics like PSD. We did a resample analysis based on Cook et al. 2015, some work done in Kansas. So essentially we're resampling the sites that we did with replacement statistically to ratchet up the sample size and figure out how many sites we should sample to meet those objectives. So just throwing this table up here, I have each pool represented by rows. It's the number of sites needed with the chase boat is the left column, the number of sites needed with the single boat on the right column. So these are the precision numbers. And a couple things I'll point out is these are pretty small numbers, right? We sample fairly precisely. We don't need a whole lot of sites to come up with pretty precise estimates of CPUE. But I'll point out the numbers on the right with the single boat are smaller than the numbers on the left, right? And so we need about 9 sites to achieve precision with the chase boat and only 6 with the single boat. And given that the chase boat caught more fish, this was a little bit of a surprising outcome. So kind of why this happened, I'll remind you kind of back to this box plots of CPUE. These high catch events that we got with the chase boat, we just didn't observe them with the single boat. So my interpretation of this is that we have some apparent gear saturation where the single boat kind of maxes out. Potentially some hyperstability. So as the abundance increases of the target organism, CPUE doesn't because we're not able to capture as many fish. So it kind of calls into question potentially some bias here as an index of abundance, particularly at those higher catches. Now looking at the catch objectives, we need obviously more sites to meet our catch objectives and our precision objectives. In general, we needed about 18 sites with the chase boat and 24 with the single boat. So the chase boat catches more fish, we need fewer sites, but it's not quite a twofold difference there, not even close. Okay, looking at blue catfish precision, only did this for the green up pools where we actually caught some fish. We kind of have obviously much more sampling to do with blue catfish. Sort of a similar story where we need slightly more chase boat sites and single boat sites to achieve those precision objectives. And again, this is, I think because of these high catch events that occur with the chase boat that we just don't get with the single boat. So it seems like we have some hyperstability with the single boat. And looking at the catch objectives, obviously we need a ton of sampling. Our resampling analysis basically got maxed out at 100 sites, so with the single boat we weren't ever achieving our catch objectives. With the chase boat we needed about 66 sites in these pools to meet those catch objectives. So to kind of summarize some of this work, we had greater catches with the chase boat than with the single boat. However, these weren't double, so adding a second boat didn't have the same proportional effect on how many fish we caught. We have some evidence of gear saturation with the single boat, right, where we had those high catch events with the chase boat configuration that we simply didn't have with the single boat. We have no real differences in size distributions between the two configurations. We have pretty high precision with both configurations, particularly for flathead catfish, where it really doesn't take a whole lot of sampling to get to fairly precise estimates of CPUE. But we had greater precision with the single boat than with the chase boat, and it's maybe not a good thing. In my opinion, this is evidence of gear saturation, hyperstability, and really calls into question the CPUEs generated by the single boat for indexing those high density sites. So we needed more sites with the single boat to meet catch objectives than with the chase boat, but again, it's not quite a twofold difference, right? We don't need double the sites with the single boat than the chase boat. And so that kind of brings me back to this original question: is the chase boat worth the spatial sacrifice? And at this point, I don't have a really clear answer for that. Obviously, we're able to achieve pretty good catches with a single boat, but it's some work still to be done to figure out whether we're appropriately indexing abundance with that single boat. So some future directions. We have one more year of this sampling planned. We're planning to move downstream into some of the downriver pools where blue catfish are more abundant to really focus on blue catfish for the next round of this. And there are many considerations still to evaluate, like the temporal period. So we did our sampling in end of May, start of June. There's, again, wide variation on when people sample, and there's still more work to be done there. Power goals, we did our power standardization based off the Miranda 2009 tables, which were not developed for low-frequency electrofishing. Still much work to be done there to figure out the appropriate level of power that we need to put in the water. And validation is an index of density. So again, are we appropriately indexing density? And this is kind of something that we typically get out with mark recapture work, and it's very difficult to do in the system the size of the Ohio River. So finally, I'll kind of put out a little bit of a call for all of us to kind of work across groups here to develop North American standards. And the next iteration of this AFS book is coming, and it's kind of an opportunity, I think, to kind of all work together to get a little bit better at standardizing this technique. And go a long way to our ability to share results and share data. So kind of a call to look for this and see what we can do to maybe advance this field a little bit. So with that, I thank you and hope I can answer any questions.
On those the runs where you were getting that really high catch rates, was there a commonality amongst those?
Yeah, and so we didn't try to look at like catches by habitat or anything like that. If there's a specific habitat type that we're encountering, and just anecdotally in the field, it didn't seem like the single boat was usually overwhelmed with fish. If you would have asked me just from sampling if it seemed like we had a gear saturation effect, I would have said no. But as that single boat has to kind of move around to go out of its way to catch fish, you're probably missing others that you're not even aware of. So that's a good question, and certainly there areas with structure and things like that produce those high catch rates, but we didn't try to take that kind of a fine look at it.
I guess the reason I ask is because the times when I wish I had a chase boat is when I'm rolling fish quarter mile, half mile behind me.
That's right.
And that's where I would think that I would benefit the most.
Yeah.
I've never swamped with fish where I can't dip them all.
It doesn't seem like it, but still, when you have a single boat and you have to move long distances, I mean, certainly there's fish that are coming up that you're just not even probably seeing, and but again, it's this trade-off, and trying to get two crews really limits the amount of work you can do and the amount of water you can cover, and that's a real big consideration here.
What were your water conductivities in the Ohio?
Let me try to remember. It was typically 200 to 400.
Yeah.
Fairly standard. Nothing too extreme. So we do some of this work in reservoirs with high conductivity and have a lot of trouble with it. But it seems like in the Ohio River, generally this technique works pretty well.
Yeah. I would think, if you're working in reservoirs with higher conductivity, like I do, and it's, you got to get to them quick or they'll snap out of it. So you'd think without a chase boat, it would exacerbate those issues.
Yeah.
The numbers that you.
Yeah, the amount of power and the role of conductivity and temperature and things like that are really poorly understood in this field, and I think we have a lot of work to do to figure out how this works and how we can standardize it. It's kind of the Wild West of sampling right now. We all do stuff a little bit differently, and it really seems like that one size fits all approach doesn't always hold up here.
Any more questions?
When you did that 2010 kind of review, did you take a look at boats that were using bow-mounted droppers versus stern-mounted?
No, I didn't try to do anything like that, and it was really just kind of a quick and dirty, run through, and I didn't try to do that. And some of the chase boat configurations will have they won't even dip fish with the electrofisher, and there won't even be dipnetters on the boat. So there's some other variables for sure. So I didn't mention we used all Midwest stuff, Midwest electrofishing systems, and a lot of that 2010 work was done with most of the 2010 work was done with Smith root gear. So there's even some some issues there too as far as what electrofishing setup people are using.
You mentioned the power output on some of the other papers you were talking about. What were your kind of average output numbers as far as?
Yeah, and so the Midwest is a little bit different, where it measures peak power and not average amps. It depends on conductivity, and just offhand, I can't remember what those peak values are, how they would translate to average amps. I don't want to say something here that's going to be way off.
Okay, thank you.
All right, thanks.